Hello everyone, this is an update on my 8-bit binary adder. I have added subtraction to it um, and generally tidied it up a bit and fixed the mistake. I didn't realise when I first done it because it just made sense to me at the time, but I had these LED, or basically everything, the wrong way round. So I had the left hand side as the least significant bit and the right hand side as the most significant bit, and that's generally not how you read binary. You read it from right to left. Oh, well, with the smallest, like you read decimal numbers, the smallest number is on the right. So I had it the wrong way around. So I've switched that round. So yeah, the input and the output are both the right way round now. All that really involved was changing the carry outs to be that way rather than that way. So the carry ripples this way now rather than that way. Other things I've tidied up. I've put the LEDs in front of the wires now, so that's a lot easier to see them. I've changed the ninth bit on here to be blue because it's the final carry out. It's not actually part of the number, so I've made that separate, and it's easier to read when it's just by itself. And it actually has some meaning that I'll explain in a bit. So yeah. Some more bits I've added. So obviously the input is on its own board now, and there's this little bit that it decides. Well, it's how you choose whether it's adding or subtracting numbers, and that's a lock switch. So I can just click it down and it stays down. And yeah, so this is the inverter board. I was originally going to do XOR gates, but it turned out that wasn't going to fit on the board. It would have been a bit easier to have just been able to do that, but I had to make this myself. I just made it up as I went along. So on this row, this side of the breadboard here, these are all inverters, and they always take the input from there and throw it in that. But the normal input also just passes straight through there to this side. So these are two gates. So one of them has the inverted input, one of them has the normal input, and this switch here just decides which gate to open and whether to use the addition or subtraction. So it's pretty simple, and that design just happened to fit on one board basically perfectly. Like I've got, what is it, like 2 rows left there, and 2 rows here are used up by these. Just transfer power over. So yeah, they just fit. So I'll turn it on and just go through some bits. No pun intended. So let's just do 1 add 1, just to make sure everything's still working with addition. So yeah, that equals 2. If I did 3 add 1, that should be 4. Yep, there we go, that's 4. And yeah, so addition still works. Actually, let's do my favourite. This is one of my favourite things. Okay, that LED... Oh no. Yeah, one of those LEDs is just brighter than the rest. I don't know why. It's the same colour. Alright, so all those are lit up, though it's hard to tell on here. And yeah, obviously that lights that up. But one of my favourite things to do for no reason is just do that and let it clears it. Basically what's happened there is it's gone all the way around, because all 8 bits set is 255. If you add 1 to it, you have 256, which clears all the previous bits that you actually care about and just adds to the final carryout. So if we ignore that, we've basically just looped back round to 0. But if you wanted to count that, that would be 256. And you can actually still access these numbers. So like if we added 2 to it, we would have 2, which is actually 256 plus 2, so that's 258 if you were to count that, or just 2 if you didn't. Meh, I don't know. I don't know why I like that, I just do. Let's turn all that off before my power regulator explodes. Right, is it hot? No, it's not hot. It's actually okay at the moment, because it's really cold in here at the moment. This is actually like our games room, so it has like a PlayStation and Xbox and stuff in here. It gets really hot when my girlfriend's playing her games. Yeah, that actually gets a bit toasty when it's hot in here. Yeah, so now let's try some subtraction. So actually, one thing I'll notice here, when you switch to subtraction, that final carryout gets just set to 1. That's because these are all actually inverted and then added 1 to it. So yeah, let's do some basic stuff. So let's do a 4 minus a 1. That should give us a 3, which, as you can see, it's got the 1-bit set and the 2-bit set. That means 3. And as you can see, this final carryout is lit up. Now, what this kind of means is that that's actually a positive number there. When that final carryout is not 1, that means you're actually into a negative number. So I'll try and demonstrate this. I get a bit confused when we start going negative, so forgive me if I make any mistakes. So let's do 1 minus 2. This should be minus 1. Right, so as you can see, the final carryout is 0. That means it's a negative number. Now, negative numbers in binary are a little different. Yeah, so it's hard to explain this, but that is negative 1. If I was to add negative 2, only this last bit would be out. This would be off, and that would be negative 2. I can show you this. So I'm on 2 here at the moment. So if I set this to 4, oh god, hold on. Negative, no. 4 minus, oh god, no, sorry. What am I doing? Yeah, okay, so that's 0 minus 2, which is negative 2. And as you can see, that final bit is there. So remember, when you have inverted all your inputs and added 1, you have to imagine that that's got 1 added to it, if that makes sense. So, or, because it's negated, it might be negative, it might be minus 1. But basically, if you added 1 to this, like assume, off is what we want, that would actually be over there and be 2. If that makes sense. It's hard to tell, right? Because when you have subtraction on, you also add 1. This is the carry in. So you've added 1, and yeah, that's minus 2. Don't ask me to explain it any more than that, because I'm not that clever. But yeah, let's do something interesting maybe. Let's set all these, right? So this should be, what was that, 255. And because the blue carryout is there, it's positive 255. If we was to minus 1 from that, you can see it literally just takes it away. Now, see if we can do something interesting. Okay, no, it's not really. Okay, let's try something else. This ain't working. I haven't got a plan here. We're going rogue. Okay, what happens if we just negate, 0 minus 255? That gives us this weird number. So that is negative. As you see, no carryout. But we've only got 1 bit set. I'm going to have to check. I think that should be right. I'll have to double check. But if we done 255 minus 255, that should be all lit, because that would be, or not a lit, because that's 0. So there you go. That's 0, positive 0 because of the blue carryout. What if we took a 1 off that? So that would be 255 minus 254, which gives us 1. So yeah. Actually, yeah, you can see it's adding up nicely, or subtracting nicely. Yeah, and obviously we can, 255 plus 255 ain't going to produce much here, because it's missing 1, so that's actually 254, plus 256 if you want to count the carryout. Yeah, it's working. Sorry if that got a bit boring. There's only so much you can do to explain addition and subtraction. Yeah, it works. Let's just put that back so when I play a bit later, you don't get confused. And yeah, that's my adder and subtractor. Not much more I can do with this. Probably in the future, I will make this again, but not on breadboard, so I'll do it on a PCB and solder it all up nicely, because hopefully that could get a lot smaller than this. This is quite a big mess. This is basically using up all my good breadboards at the moment, so I'd like to take it apart. But yeah, have some other ideas for my next projects. I don't really want to do another discrete project, like just using discrete components, because that gets quite crazy. So I'll be doing some IC projects because I've got some cool ideas for that. That I'm quite eager to try, and they shouldn't take as long as this, and I can keep them hanging around for a while. But yeah, thanks for watching, and goodbye.